Thank you very much. This is a very interesting, there are some topics of IoT that was discussed earlier. And but one thing that we need to look at it is what are the fundamental elements that we are trying to achieve, whether it is AI, whether it is IoT, or whether it is any kind of analysis or analytics that we do. So the first thing that I would like to say that yesterday when I was coming back from Bombay, I will share an experience. So it was yesterday at around 11:06 a.m. p.m. And I was coming from airport to residence, and at a specific location, I was traveling on an Uber, and I got this message. Your vehicle's been stopped for a while. Please let us know if everything is okay. Okay? And there were two options for me. One is it's okay, to select it's okay. And the second option is to get help. Okay? Now this is just, I am traveling and I'm just heading to my residence, and this is what came at a specific location. Now if I add a little bit more dimensions into it, so suppose I add, if you know that it's a secluded area, if somehow you knew that it is a secluded area and it's raining, the context of this message may completely, or the severity of this situation may be completely different. Okay? Isn't it? And if I add another dimension to that, say a gender and an age group. When I say age group means if I know if a woman or a female is traveling in that, or a family is traveling with a child, okay, in a secluded area, in a rainy season, and the vehicle is stopping for unwanted reasons or something that is not related, then the context of this decisioning element that you are seeing is completely different. When we talk about probably safe cities and so many incidents that happen, this simple adding a dimension to that changes the whole context of the game. Now, if I add another dimension to it, that there was a traffic congestion due to which it had stopped. Now, the severity suddenly falls, because traffic congestion, even if it is a secluded area, it's raining, you don't really attach so much of a severity, it may become natural. But if you see the decisioning side of it, what are the fundamental building blocks that you're seeing here? One is data, correct? That data is real time, right? There are some decisioning rules that they're making. They're identifying whether the vehicle has stopped or not. They're identifying whether it qualifies for sending an alert or not. And if I add other context, there are many such rules, predictivity of the aspect needs to be considered. And then the decisioning element of reaching a person, an outreach should go or not, is the decisioning element. And taking the feedback, suppose I say it's okay, then means it's a false positive, right? I'm fine. You unnecessarily incurred a cost of reaching out to me. It's a normal situation maybe. So that's a cost, that's a penalty that will go in. So you need to learn over a period of time. Now if I want to integrate this with temporal aspect, that before 30 minutes or 45 minutes, at the same spot, there were many people who were facing the same situation. So if Satyajit Dwivedi is the 16th person facing the same situation, should I incur the cost or not? That's also a very important element. So you see that data, real-time application of predictability, the decisioning, the feedback, and the learning mechanism is available in a simple system like this. It's not simple. I would say a simple use case like this. But if you look at it, millions of people travel across a network on all dimensions. So temporal dimension, spatial dimension, if you look at it, this becomes a very, very important element that one needs to look at it. Even if you attach safe city, even if you attach gender equality, if you attach, women traveling, if you extend it to public transport, you integrate, panic button systems in this. There are hundreds of possibilities that can be achieved. And with now in many other countries, I have seen There are cameras inside the car which can count the number of people. It can know which are the gender. It can identify the age. It can identify child. It can identify whether they are, belt is properly fixed or not. So many other things are coming up as a set of any kind of a mobility, modernization. There are cases of, we saw some responsible AI or not, but when it comes to safety, this is a whole different dimension, and regulations are there to, protect this. So if you see here, if I ask you, who is behind you sitting in a blue color shirt? Suppose I ask you, will you be able to tell me? Huh? Without turning like this 360 degree, you won't be able to tell, right? But today, if because you have two eyes, I mean, we all have two eyes, right? But if you look at mobility vehicles today, they have more than 8 cameras. They have 2 on the front, 2 at the back, 2 at this side, 2 at that side, monitoring a complete 360 degrees so that they know they can recreate the scene of accident, they can document everything. They are becoming more and more, equipped to take decisions rather than simple human beings. As human beings, that is why we need the third eye, I call it. The third eye is the AI. Okay, everybody, we cannot escape that. We have to need the third eye that's there. So when it comes to IoT, sometimes this is very, very critical to understand that what's the context behind it. That's one message that I want to say. Just one example, taking it forward. This is Reshape, which is a water and road transport authority in Netherlands. It has got its, as you know, Netherlands, it's a low-lying area. The 100% of the transportation almost is happened by waterways, river and waterside. And they had put around 450 measurement locations, 2,000 sensors generating 6,55,000 points per second. Do you think it is, what was the purpose behind it? Why would they do this? Why would they set up these sensors? Why would they collect this data? How would they benefit out of it if the sheer objective was to collect the data and store it somewhere in a database or a big data lake or whatever that it is? What's the benefit of it for them? So unless and until you leverage these assets, the data, if you look at it, their main focus was smart water management. And smart water management, because when you are having waterways that are there are a lot of barrages or, gates. The gate operation becomes very, very important during high season and low season, right? Because there might be ships coming in and there might be ships going out, okay? So it is very, very important to monitor and manage the level of the water. Otherwise, you will not be able to manage the draft and the type of ships that are coming in, what kind of draft they need. All these things needs to be looked at it. So they did, that was the first. Second is, they took the motor data, temperature data, to see that they are not running in overload conditions. Because if I am not able to operate the gate of any, specific location, I will be having challenges of being stranded or the logistics getting impacted. And the third is the flood management, flood defense strategy. It's very, very critical to see that it is not important to only collect data from sensors. And 6,55,000 seconds, even if I give 655 data points to a person every second, he will close his eyes after a certain point of time. It's impossible for us to, as a human being, we have some limitations as far as processing is concerned. Our, HPUs, human processing unit, I call it, are not as capable as what you are seeing from a processing standpoint. Sorry, I have a call, but it's okay. Can you minimize that? Yeah. Going forward, this is something that I wanted to say that things are changing. This is for Georgia Pacific, one of the big firms that we are working with them. And they had automated guided vehicles, AGVs, operating in their warehouse. And this operation, they wanted to make it more efficient. And that's where in some of the cases, I think in the airport or the aviation presentation, there was a mention of digital twin, where they are they talked about replicating a airport itself. Now, most of our planning, most of our designing that happens, or most of our investigation that we do is based on digital twins. You need to have, you cannot physically go the site, you cannot go there and mimic everything again. You cannot physically alter anything before taking any decision. So this was basically trying to build a digital twin of their complete automated guided vehicles, AGVs, to optimize the performance, optimize the number of vehicles that we'll use based on the load characteristics, based on where the location was, based on what kind of products are needs to be taken and deployed where. And it is not only that. Today, if I want to take a digital twin just for the heck of it, it may not be solving any purpose, right? You need to look at it from a point of view, how I can optimize this. If I alter a design, how does it impact my cycle time? How does it impact my operational efficiency? So those kind of mechanisms needs to be seen and integrated with AI to be able to real-time data can come in, simulated data can come in, you can alter the configurations, you can run optimization simulations, and you will be able to read the output that what you are seeing, suboptimal number of vehicles, variables. So it can recommend what is suboptimal. It can also recommend what is optimal, because at the back end, when you click on that, you are actually seeking an optimized output. So therefore, if I have a digital twin for the sake of it, doesn't matter. But if you are able to use the digital twin for real-time simulation, for real-time optimization, for real-time scenario planning, that's fundamental that one needs to look at. The second thing that, if anybody of you have already read the, public sector report, it's sometimes, one needs to look at not only it is not your data. In the first example, it is probably IMD data that I was referring to, but used by somebody else. So there are multiple authorities, multiple departments that needs specific data which is having a custodian somewhere else. The data custodian is somewhere else. The interoperability becomes very, very critical, not only at the system level. I would say that the interoperability between the departments is more critical, between ministries, between the agencies that own this data, that control data, is more important than interoperability in the technology side. Because if you even have a interoperable technology that is thriving, because interoperability is not having in the departmental frame of mind, then the results that you will get is very minimal, or you will not be able to maximize that setup. So this is a case that we had done where the water security or the water risk was there's a country where the water risk is very high, and there's a lot of challenges around that. They changed the entire governance structure of the entities and came out with a water authority that will actually take the data from all the entities, from the desalination, from the all the supply sources, right through the reservoir to the distribution side, to the wastewater treatment and to the recycle element, to be able to understand what is my non-revenue water, what are my recycle percentages, how are my wastewater treatment plants are performing, how is my desalination plant performing, are there any production related outages that I'm looking at, what is the demand forecast, am I achieving a supply-demand balancing on a dynamic basis. This is how agency collaboration needs to drive the overall setup, and this is all possible because you need to look at integration of all the IoT elements. You need to apply AI to be able to identify such opportunities. The second is, this is one bit we are doing where flood and traffic. When you have flash floods and when you have traffic situations, then how do you manage your adaptive traffic controls to be able to look at that if there is a flood situation, if I am able to identify which network gets impacted, what is the alternate route or what is the signal time that I need to change? How would it impact based on the ridership or the density, traffic density that flows in that particular intersection or that particular corridor or that particular area. The other element is that when you have data, a lot of data gets talked about, a lot of storage, big data lake. I've seen many big data lakes that are there in many systems. They are only dumps of raw data. But unless and until you attach a context behind it, and this is what we had done for Department of Environment Protection, Water Resource Department in Florida, where it was driven by clean water program. They had a clean water program. They wanted to identify, they wanted to target specific basins. They wanted to, all the hydrology unit codes, HUCs that they call it, right? Not at a basin level, but down below, at a small watershed level, in fact. And they wanted to identify where should I target, where should I improve, and also know the attribution, why water quality is bad. Now, this all needs to be integrated across multiple agencies. Remote sensing data needs to be brought in. All the inspection data needs to be brought in. All the water quality data needs to be brought in. And then with the geospatial setup, you need to analyze this information to be able to take very targeted, very specific context-oriented decisioning. That's one. So what is fundamental in this? I don't want to go into more use cases. What is fundamental is this, of course, there is data, innovation is data. And here, the data realm has changed a bit, either available data or synthetic data, but synthetic data with a caution that there are many caveats to that. One has to carefully look at it. And the fastest growing thing is that we are sensorizing anything, remote sensing, sensors, whatever is there, we would need to look at it. But this is the whole frame that one needs to see, how it is changing. The entire analytics life cycle from the data management to decisioning is changing with three things that is happening. And this is what future-proof government architectures should look at. One is the simulation capability with digital twin, the synthetic data part along with the digital twin simulation. On the other side, we have a lot of generative AI. I think in one of the cases, LLMs were discussed and all that. I think in the talk of, from MIT, I think he, or India mission, he referred to that. But these are localized, needs to be localized, need to be department specific, need to be region specific as well. And because it summarizes a lot of things that one structural data may not be able to provide you that. The other is the quantum part, the quantum AI or quantum optimization. Because when you have large scale data flowing into the system, any optimization will have its limitation unless you hardware from an infrastructure point of view, you are able to build that. So that is one element that needs to be looked at. So this whole platform of orchestration, which I think Ensley was mentioning in one of the panels, that the agentic AI part needs to be also looked at. So this whole orchestration of these elements that you are seeing in this slide is what is going to drive AI at scale for any organization, for any ministry, any department that we are talking about. So net, what we see, value is important. What you are getting out of it is important. What your context is important, not the data itself, not the storage itself. You need to understand and act. That is what is needs to be looked at when you look at IoT. And there are accelerators that can be driven because you can put it in any cloud, on-prem, in any cloud premises, but it should be, without any lock-ins. You should be able to host it in Azure, you should be able to host it in AWS, you should be able to host it in Google. But there are certain accelerators that you need to look at from a 3 to 5 year plan. And these are driven by certain, standards that SAS EMEA platform also helps you. This is an example of natural resource management. So you could do all the things highlighted in the top half. Similarly, for transportation, you could look at the same platform could support, driver risk score, to support zero accident program, infrastructure risk part of it, smart monitoring violation and fines. Lot of use cases that can be delivered through these systems. So this is what it is important that if you blend AI and IoT, so IoT was born out of IT and OT, sandhi of that, which was IoT. But AIoT is something where you fuse AI with IoT. That becomes AIoT. And that is where we have seen that when you When you integrate AI with IoT, you will definitely get significant benefits out of the raw data, out of the real-time data that you are looking at. And this is a survey that it exceeds expectation, and it gives a competitive advantage also. And that is what somebody should look at it when you are looking at across state, across districts, when you are looking at replication. You need to have that competitive spirit. May not be advantage from a trade point of view, but definitely from an operational efficiency, from productivity point of view, this is extremely critical to look at it. And we have done this kind of work across the globe. As far as smart government is concerned, with infrastructure, electricity, transport, and water. And these are three domains that are extremely critical to highlight. So with that, I end my presentation. Thank you so much.